we can use an integral test to show that the series is convergent. However, if we want to approximate the sum S of the series, we can use the partial sum S of n at n approaches infinity to estimate. But how good is this estimation? To answer this question, we will need to estimate the sign of the remainder. The remainder R sub n is equal to the sum minus S sub n, and that equals a sub n plus 1 plus a sub n plus 2 plus a sub n plus 3, so on and so forth. The remainder R sub n is the error made when S sub n, the sum of the first n term, is used as the approximation to the total sum. Okay. So let's take a look at in the first picture. Here we have the integral. From n to infinity of f of x dx. And these are the a sub n plus 1 plus a sub n plus 2 plus so on and so forth. And that is equal to r sub n. And it will be less than or equal to this integral, right? Now, here we can see that r sub n, in this case, is equal to a sub n plus 1 plus a sub n plus 2 plus so on and so forth. In this case, it will be greater than the sum from n plus 1 to infinity of f of x dx. Note that in the first case, we started n. The second case, we started n plus 1. Okay. So then here we have the following error estimated here, that suppose f of k equal to a sub k, where f is continuous, positive, decreasing function for x greater than or equal n, and the sum a sub n is convergent. If the remainder equal to s minus s sub n, then the remainder is in between that two integral. So adding s sub n to each side of the equation, we get the formulas here for the sum. So it is somewhat in that interval. Let's see how we put that to use. We want to approximate the sum of the series 1 over n to the third by using the first 10 term. We estimate the error involved in this approximation, and we want to see how many terms do we need to use in order to have the sum is accurate to 0.005. Okay. So first of all, we'll start with our integral. The integral from n to infinity of f sub n of f of x, that is 1 over x to the third dx. This equal to the limit as b approaches infinity of 1 over x to the third. Evaluate from n to b. That is the limit at b approaches infinity of negative 1 over 2b squared plus 1 over 2n squared. And as b go to infinity, this equal to 1 over 2n squared. Okay. So if we want to use this in the first 10 term, then the sum at n equal 1 to 10 of 1 over n cubed is approximate the sum s sub 10. And we can use this we can do this in our calculator or Excel, and we get this value to be about 1.1975. Okay, so according to the remainder theorem, this means r sub 10 is less than or equal to the integral beginning at 10 to infinity, the 1 over x to the third dx equal 1 over 2 times 10 squared, that equal 1 over 200. So that is the remainder. So the side of the error, so the error is at most 1 over 200, that is 0.005. Well, the next thing is, how many terms do we need in order to get something that is in between 0.05? Well, we was told that r sub n is less than or equal n to infinity of 1 over x to the third dx, and we get it earlier, that is 2n squared. And if we want this to be less than 0.0005, I can solve for n in this case. And we get n is greater than square root of 1000. That is about 31.6. Okay. So this means if we want the sum to be accurate within 0.005, then we have to use 32 terms. So we need 32 terms.